classroom. So if you are not done, you can either just pay attention as you're going through it and just watch. If that's easier, you can be making changes. It really doesn't matter, but you're going to be able to see the answer key on Google Classroom. So even if you want to just leave them blank and try them on your own then tonight and then go back through and check again, because I will tell you this covers a lot of different concepts. And like I said, last class when I was going over it, I was seeing a lot of people making fixes and a lot of people needing to finish things up. Okay? You had almost an entire class period to work on this so far. So that means tomorrow, it's probably going to take you a decent amount of time to get through the test. Okay? So make sure you're studying so you know what you're doing. So the first one asks if they are congruent. Remember, congruent means that they are the exact same shape, exact same size. What's a translation, guys? Slide. What is a rotation? Turn. What's a reflection? Flip. In any of those cases, did the size or the shape of my hand change? No. Okay, so that would be congruent. What's the one that makes it similar? Anybody? Dilation. Good. Okay. So as long as they're the exact same shape and size, they are congruent. If you're looking at this, if I go from here to here, I rotated 90 degrees. So I did one turn, and I turned it following the clockwise to the right. Okay. If you did not have the and translate, okay, then it's totally fine. It's not going to be that if you didn't have that, it's wrong. However, we don't know a point of rotation, so there could have been a translation at the end. So that's why I included that. But if you just had this, that's fine. If you just put rotate, that's not enough information. Okay, I don't know if I turned it 180 degrees. I don't know which way I turned it. Okay, so make sure you're being a little bit specific there. On the next one, congruent. Okay, exact same shape and size. So I know they're still congruent. This one, I was flipping it left and right. That's my y-axis that it crossed. Remember, if it goes this way, that's my x-axis it's crossing. This one you do absolutely have to have the translates as well, because you can see if I flip it this way or this way, then it is moved up or down, okay? You didn't have to tell me which one, because I don't know which one's the pre-image. It either went up or it went down. If you specified, I would not count it wrong, since we don't know which one's which. But you do have to have both parts. On this one, you do have to tell me which way I'm reflecting it, okay? Any questions on the first two? Next one, you're going to have to name your angles and your sides. Guys, when you take your test, you can feel free to use your highlighters, okay? I actually use the highlighters a lot throughout this review. When you're looking at the angles, make sure you're using the angle symbol, make sure you're using capital letters, make sure you're using the congruent symbol, and you pair them up based off of the arcs. So W and X both have one arc. If you said angle X is congruent to angle W, same thing. Okay? Then I have angle U and angle Y, both have two arcs, so they're congruent. Angle S and angle T both have three arcs. They're congruent. For the sides, you have to match up the arcs. If I go one arc to two arcs, I have to go one arc to two arcs. Notice, I like to use the colors here to make it clear for you. If I go yellow to pink, I cannot go pink to yellow. That's not the same thing. The order matters. Okay? So if I have WU, this one has to be XY. If I have UW, this one has to be YX. They have to go the same order. If these were flip-flopped around, that doesn't really matter. It doesn't matter which one you start with. US, 2 arcs to 3 arcs, and YT, 2 arcs to 3 arcs. Then I have 1 arc to 3 arcs, WS, so 1 arc to 3 arcs, XT. You should have the same amount of angles and the same amount of sides. Okay. The next one's the same thing except there's no picture. I actually think it's easier when there's no picture involved because they give them to you in the correct order. You don't have to try to match them up. The first one with the first one are congruent angles. The second one with the second one are congruent angles. The third one with the third one's congruent angles. So angle X is congruent to angle C. Angle V is congruent to angle B. Angle N is congruent to angle M. Then, same thing with the side lengths. The first two is congruent to the first two. The last two is congruent to the last two. The first and the last is congruent to the first and the last. Once again, if you would switch them, like instead of doing first and last, if you did last and first, the other side has to be last and first. They have to go in the same order. A lot of this chapter, order matters. Okay? On the bottom one, you are just drawing in the arcs and the ticks. My arcs are in the angles here. L and E were already done for you. Okay? When I did F and M, you could have one arc there, you could have two arcs there. It really doesn't matter as long as they're marked the exact way for F and M the same. Okay? G and N have to be marked the exact same way. Then for my sides, your bottom one here and your top one here should be marked the same because it's two arcs to a box, two arcs to a box. The ones on the left and the right should be marked the same. One arc to a box, one arc to a box. And then these should be marked the exact same. One arc to two arcs, one arc to two arcs. Are there any questions? Front page. Okay, flip it over. On the next one, I always have people that get this wrong. And a lot of times on the test, it's not because they're even really doing it wrong. It's because people get overwhelmed by it and tend to end up skipping this. Don't skip it, guys, okay? At least give your best guess on it, okay? So the first one, you have to first graph the original. So 0, 2, 4, 1, 2, -1. My blue one is my original. Then it says reflect over the x-axis, okay? If we're going over the x-axis here, that means if this one went up by 2, now it goes down by 2 from the x-axis. If this went down by 1, now it goes up by 1. If this one went up by 1, now it goes down by 1. So here's my new figure. If that's really difficult for you, you could remember the rule from last chapter. If it's the x-axis, the x value stays the same. So 0, and then the y becomes the opposite. Keep the 4. The y becomes the opposite. Keep the 2, the y becomes the opposite, and I'd get the same thing. So do whatever's easier for you. Go by the rules or go by the graph. Then the last part, it's 4 units to the left, so I just counted on each one. 1, 2, 3, 4. There's my first point. 1, 2, 3, 4. There's my second point. 1, 2, 3, 4. There's my third point, and wrote them down. Because we were using reflections and translations, they are still congruent. Remember, reflection, rotation, translation, all of those keep it congruent. Dilation is changing it. Then it would be similar. On the next one, I have written out way more than you need. Okay, I just wanted to make sure you understood. In this one, we start by knowing angle LHK. Remember, you always kind of look at the middle letter to know what we are looking at. LHK is this one right here. That angle is 71 degrees. Then they want the measure of angle JHK. So JHK is this one. Again, it's really looking at that angle H in that triangle. And I know that because of the way they were named, those are corresponding. Since we know they're congruent, corresponding are equal to each other. So if this one's 71, this one's automatically 71. So you didn't have to have all of that written out there. You could just be telling me that that angle is 71 degrees. Okay? But that's the explanation for it. Number 8. On this one, you had to say similar, congruent, or neither, or not enough information. On this one, you had to take 180 because every triangle's interior angle sum is 180 degrees. We learned that 2 chapters ago. So 180 minus the 2 angles I know gave me that missing angle was 84. On this one, 180 minus the 2 angles that I know gave me this angle was 37. And I see angle A and A prime are equal, angle B and B prime are equal, and angle C and C prime are equal. So these are similar. Okay? They are not the exact same size. You can clearly tell the side lengths are different, so they're not congruent. But they are similar because if all the angles are equal, that means they're the exact same shape. That means that's like when on a picture on your Chromebook, you click and drag the corner, and if you do the corner, then it still stays the exact same shape because it is getting bigger proportionally. Okay? Number 9. I have a lot of people struggle on number 9, but you guys did really well on the homework with it. So it's just a matter of knowing what to be doing. Okay, on number 9, if they are similar, for the side lengths, they have to be in the same ratio. Okay? So to be similar, they have to have the same ratio, meaning every side was multiplied by the same thing. So it's like there was one scale factor to it. So it really does not matter if you guys just watch up here. I see a lot of you writing. I want to make sure you catch this. It really doesn't matter if you're doing 4 over 2 or 2 over 4. Once you find your corresponding parts, this part, it doesn't matter because we're just checking to see if they are the same. However, if I did this one first for the first ratio, I have to make sure I'm doing this one first for my other ratio. Okay, so if I'm doing 4 over 2, I have to do 8 over 4. If I would do 2 over 4, I'd have to do 4 over 8. Okay, and on this one I find that they are the exact same. Because the ratios are equal, they are similar. Because the ratios are equal, they are similar. On the next one, if I count, this one was 7, this one was 3. So I did 7 over 3. So since I started with the bigger one, I have to start with the bigger one on the other one. And this side was 4 when I counted, this side was 2. 4 over 2 is 2. Since the ratios are not the same, they are not similar. They are both triangles, but they're not the exact same triangle. Okay? A lot of people get that confused. They're like, yep, they're both triangles, so they're similar. Nope, that doesn't mean they're the exact same shape. They have to be the exact same type of triangle. Exact same angles. Any questions on that page? Okay, I want to skip number 10 because after that is just like this. Okay, and I want to make sure you guys are understanding 11 is the exact same thing. Okay, yes, I know that when you're looking at it here, they look different because this one's on grids, this one's not, but they're asking the exact same question. So here we were checking to see if the ratios were equal. Here we're going to do the same thing, we just don't have to count them. So I found my corresponding parts. I used my arcs to help me find the corresponding parts. And remember, whichever one you start with, you have to start with every single time. So if I did the big one over the small one, I have to do the big one over the small one. I have to do the big one over the small one. And they all came out to be the same thing. So yes, they are similar on that one. Okay. Any questions on 11? Do you guys see how 11 and number 9 are the exact same thing? Yeah? Okay. Alright, I'm going to go back to number 10. On 10, we've actually done this exact problem. Okay? I believe it was a homework question that you guys did, and you did really well on it. So we have our original picture, 2 inches by 2.5 inches. Then we have a scale factor of 4. So we multiplied by 4. When you multiply, you have to multiply both parts. Remember, anytime it's a dilation, anytime it's scale factor, that means you are multiplying. It's getting it that many times larger. So then it was an 8 by 10. And then it said it goes one more time with the scale factor, but this time the scale factor is 12. So then I multiply both parts by 12, and I get 96 inches by 120 inches. The last part asked if they were similar. Yes, they are, because this is a dilation. Anytime it's a dilation, everything is changing the same way for the corresponding parts. If they're all changing the same way, they all have equal ratios, that means they will be similar. They're the exact same shape, just different size. Unless, obviously, your scale factor is 1, then it stays the same, then it would be congruent. The rest of this page, guys, is all proportions. Okay? Gotta know how to solve a proportion, otherwise you're going to be missing like 4 problems on your test tomorrow. This is a part that I would definitely have my highlighters out. I learn better in color. It helps me see the corresponding parts as I'm going. So that's my suggestion to you, is to use highlighters, but it's really up to you what you choose to do. On number 12 says, this pair of polygons is similar. Find the missing side. So since it's similar, we can use a proportion. We know the ratios are equal, so we can set our 2 ratios equal to each other and solve. So you can use whatever parts you want, but you have to use the side with the x. I did the x on the top, so if I want the bigger one to the smaller one, x over 10, then I have to find corresponding parts for my other one. I did 22.4 over 14. You could have done 9.6 over 6. Really doesn't matter. Either way, when you do your cross products and you solve, we're all going to get the same answer. The other thing, remember, is even if you set up your proportion differently, like maybe you did 6 over 9.6 equals 10 over x, it would still be the same thing, because when we look at our cross products and solve, we'll get the same answer. You really should be just making sure your diagonals are the same thing. Okay? 14 times x is 14x. 10 times 22.4 is 224. Divide by your coefficient and you get 16. We've actually done that exact problem already. Number 13, you should end up with 262.5 feet on this one. I drew a picture. You don't really have to draw one, but it helps me find my corresponding parts easier. So I have my arch's height was 630 feet, and we did not know a shadow length. However, for the other one, the 12-foot pole, I did know the shadow length was 5 feet. So I highlighted my corresponding parts, and I did the smaller one first on this one. Remember, I usually star whichever one I start with, so I know to start with the exact same one on the other half. So I did 12 over, 630. I almost said 360. Okay, 12 over 630. So the other one was 5 over x. Okay, then you do your cross products and solve. So 12 times x is 12x. 5 times 630 is 3,150. Divide by 12 on both sides, and you get 262.5 feet. Okay. Any questions on that one? Last two. When you are doing your proportions, first of all find the corresponding parts, and then make sure you are matching them up. If you go bigger triangle to smaller triangle, I did h over 6.5 or 6.5. Then I have to go bigger triangle to smaller triangle, 31.5 over 9. You do your cross products, and you solve. Again, even if you set this up differently, you should still have 9 and h at a diagonal, even if it's going this way. Even if your 9's here and your h is here. Okay? We should all have the same cross products on these. On the next one, you might have to use like your arcs to help you find the corresponding parts. This one I did the bigger one to the smaller one, so I did d over 10 is equal to 45 over 21. I multiplied at a diagonal. 21 times d is 21d. 10 times 45 is 450. Divide by 21 on both sides, and I get 21.4 meters. Any questions there? Flip the page when you're ready. On the last part here, this is probably the ones that's like the most missed, and it's truly because people are not sure what's being asked. So really make sure you're paying attention to this one. And tomorrow, if you're not sure, you can always ask me a question. I can't guarantee that I'll be able to help you through it, but this is what the expectation is. So you're supposed to graph each pair of triangles. So the first one, -6, -3, -6, -3, -3, -2, -3, -3. There's my first triangle. Then I did my second triangle, 0, -1, 6, +1, and 6, -1. Now, we learned that if they are similar triangles, they are going to lie on the same line. Okay, the hypotenuse of the triangle is going to be on the same line. So, you have to do two things. You have to write a proportion, and you have to tell me the number value. A lot of you are really good at telling me your rise over run, saying my rise was 1, my run was 3. That's great. This is the part people struggle with. My rise was not only 1, but the name of it here was DE. My run was CE. I'm okay if you switch these around, okay? Like, not switching them this way. I can't do run over rise, but like if you had ED instead of DE, I'm okay with that, okay? On the next one, my rise was NO, my run was MO. So I have my rise over run equals my rise over run. Same thing over here. I graphed my first triangle in pink, RST. Then I graphed my second triangle in black, UVW. And since they are similar, they should fall on the same line. That means they have the same slope. When I look at it, my rise is RS, my run is ST. My rise is UV, my run is VW. And on this one, if you are not checking anything else, pay attention to this part. Do you see how the line is going down this time? That means my slope is negative. You have to have a negative here. Went down 3, right 2, so that's negative slope, -3 over 2. And your sentence, we've already talked about these things as I explained it. But notice that the similar triangles have slopes that are equal, which means they lie on the same line. Similar triangles will always fall on the same line because they have equal slopes to each other. Okay? 16 should be pretty easy. This was the last lesson. If it's perimeter, we multiply. Go ahead. If you need to go to the restroom, you can. Okay? Because it's perimeter, you multiply by the scale factor. Okay, if you just had K, I'm fine with that as well. If it's area, you multiply by the scale factor squared. Okay? Either by the scale factor if it's perimeter or scale factor squared if it's area. Number 17. This one was easier than you probably even realized. It gave us the scale factor. You didn't have to find it. It said it's twice the length. That means it multiplied by 2, just like our notes that said doubled. Okay? And it gave us the perimeter was 16. So if I know my perimeter, I multiply it by my scale factor, and that's my new perimeter. So it's 32 inches. Number 17 looked like the last few on the homework for 7-7. And on these, you had to first find your scale factor. So my one with all of the information is my pre-image. So one side is 6 inches, area of 36 inches, or square inches. That's my pre-image. My image is the other one. Okay? And so I did 3 over 6, image over pre-image, to get my scale factor of 1/2. Once you have your scale factor, I can take my area times, and we said the scale factor squared right here, gives me my answer. Notice you absolutely have to have parentheses there. If you do not have the parentheses, your calculator will not understand what it's doing. It'll think it's only squaring one of those numbers, not both the 1 and the 2 in the fraction. Okay? Make sure you are labeling that one appropriately. It should be 9 inches squared. Okay? On the last one, a lot of people don't understand it just because they're confused at what the question is asking. If you are looking at this, if the scale factor is 3, when it's perimeter, we multiply by the scale factor, which was 3. If it's area, we'd multiply by scale factor squared, which is 3 squared. Okay? If my scale factor is 1/4, if it's perimeter, we multiply by 1/4. If it's area, you multiply by 1/4 squared, but how do you have to write it? In parentheses. Very good. Okay, are there any questions on the back page at all? Okay. Please make sure you are studying. Like I said, this test usually does not go as well as the last one for people. So make sure you're looking over, make sure you're coming in with any questions tomorrow that you might have.